Hi, everyone. I want to show you how to run the chi-square test of independence. And I'm going to do it two ways. One, I'm going to conduct a test when we have summarized data that's already summarized or cross-tabulated into a table. And then I'm going to do another example where we have raw data. So let's start with this first example here. It says in May 2014, Colorado became the first state to legalize recreational use of marijuana. And we have a poll of 1,000 adults who are classified by gender and their opinion about legalizing marijuana: legal, not legal, or unsure. Genders here, men, women. So these are two categorical variables. And in this case, we have an explanatory variable that's gender, and the response variable is opinion about legalizing marijuana. And in this model, we want to show, is there a difference in the response due to the explanatory variable? So how you write your null and alternative hypothesis for this test, and you can see the data here. Before I do that, I should point out on the data, you can see that men seemed more likely to support legalization of marijuana, and women were more split, slightly opposed. So that could be due to chance, and that's what the chi-square test will tell us. So the null hypothesis says there is no difference about opinion, in opinion about legalizing marijuana due to gender, and the alternative is there isn't a difference in opinion about legalizing marijuana due to gender. In this test, it's the same as saying, are legalizing marijuana and gender independent events, or is this opinion and gender dependent events as the alternative? And again, the model is called the chi-square test of independence. The degrees of freedom for this test is the number of rows minus 1 times the number of columns minus 1. So this test is going to have 2 degrees of freedom. And let's test this at, say, an alpha of 5%. So I'm going to pull up the minitab for running the test now. So the data is shown in this table right here from columns 14 to 15. So you can say we've got the legal, the not legal, unsure. And when I put the data in minitab, I want to make sure not to include the totals. So the total, it will be summed up by when we run the test. And how we run this is under stat, tables, chi-square, cross-tabulation and chi-square, the middle one. So I'm going to pick that one. And it's going to give me some options. Now it says, do I have raw data? No, and this time I have summarized data. So I'm going to pick summarized data. Then you just pick the columns that contain the data. And we can see the data is in columns 15 and 16. So I'll pick those two columns. And then the labels for the rows are in column 14. So I'm going to add those as well. And usually what I do is I say, I want the counts. And I want to go now to chi-square. And I'm going to say, do the chi-square test. And we're going to put the expected cell counts, which is the row total times the column total divided by the grand total. And then each cell's contribution to the chi-square. So for each cell, we do that O minus E squared over E calculation. We'll let minitab calculate all that for us. And you just run the test. And here you can see the results of the test showing that, okay, here's the cross-tabulated data. The first variable shown is the observed, the 270, 230. The second variable shown is the expected if the null hypothesis is true, if there's no difference. And since there's 500 of each, they should be evenly split in all groups. And you can see that. And then the last value is the O minus E squared over E, the 1.6. So 270 minus 250 squared divided by 250 is 160. And you can see that when we calculate the p-value for this test, we get a total chi-square statistic of 6.76. I'm just going to copy this part of the test. Copy this picture. It'll give us the value of the chi-square test. So I'll go back here and say, okay, here's my results. P-value less than alpha. P-value is 0.034, less than 5%. So that means I reject the null hypothesis. And the conclusion is just going to be HA in words, saying there is a difference in opinion about legalizing marijuana due to gender. That's my conclusion, right? Okay. So now let's go on to what we can do if we have raw data. So I'm going to go to another example, and this is the study we showed earlier about Airbnb. So in 2016, Harvard Business School conducted an experiment on Airbnb. And what they did is they created, I'm not going to read through this whole thing. I'll leave it here. It says they created all these fake profiles. They looked at the birth records in Massachusetts between 1974 and 1979 and created a bunch of fake profiles with people that age. 10 of the profiles had distinctively African American names, and 10 of the profiles had distinctively white names. And they made all other characteristics of the data the same, and they wanted to see what was the what was the chance someone was rejected by the host just based on how their name sounded. And that's what they were looking at. So they controlled for all the other variables. So we have two categorical variables in this data, the race, white or black, and the response variable. Were they accepted by the host, yes or no? So there's, it's a 2x2 variable, and the null hypothesis says there's no difference in Airbnb host acceptance due to race. And the alternative said there is a difference in Airbnb host acceptance due to race. Another way of saying that is that Airbnb, their acceptance rate and race are independent or dependent events. So we can conduct the chi-square test of independence on this, and I have that raw data right here. Here's the Airbnb data, and it's over 6,000 records. And you can see we've got names that sound distinctly black, names that sound distinctly white, and we just want to see if the acceptance rates are different just on how their names sound. So yes or no, were they accepted by the host? So how you run the test here is you cross-tabulate it, and when you cross-tabulate it, you can also run the chi-square test. So I'm going to go to Stat, Tables, Cross-Tabulation, and now here I'm going to say I've got raw data. So it doesn't matter which one you pick for the row or the column, you got to pick one for the row and one for the column. So I'm going to pick, I will pick race for the row value and were they accepted for the column value. And then do what we did before. Go to the chi-square option, click the chi-square test, the expected, and each cell's contribution to the chi-square. Click OK. And here's the results. I'm actually going to copy both of these. So let me copy, this is a picture first. Come back to here. I'm going to go ahead and put that on a new page. OK. So here's the results, and you can see that of the experiment. So for the names that sounded black, 1270 were accepted. If it was independent, if race didn't matter, 1403 should have been accepted. And for the whites, you can see that more were accepted than expected. So there seems like there is a difference here. And that's what the chi-square test will tell us. What's the difference between the observed and the expected? Again, you can see the components of the chi-square. We take the observed minus the expected squared, divided by the expected to get the 1035. I should also point out here, this is where you check that the expected is over 5. And clearly, these four numbers are way over 5, so not a problem there. I'm going to go back now and get my p-value. And you can see the p-value is basically 0. So the evidence is overwhelming. When you have a chi-square of 45, a chi-square is 1 degree of freedom. So the expected value should be 1, and we got a value of 45. So pretty strong evidence that the p-value is basically 0, which is less than anything, less than 0.01. So we reject the null hypothesis, right? And the conclusion would be there is a difference in Airbnb host acceptance due to race, right? And you could even say that profiles with black names, I guess, are accepted less often than profiles with white names. Okay, so that's how you run those tests.